Hello everyone, in this video we are going to create the trammel animation as seen in my videos here. This is a pretty fun one to create and it shows you how to animate mechanisms. Let's get started. So I'm going to start off by importing the 3D files. So file, import. I'm going to import the STL files. Base. Well, we need to delete the cube first. And so now we have the base imported. I'm going to rotate it on the x-axis 90 degrees. Here we go. I skipped the part of the video where I set up the light, but now it is time to set up the crank. So we're going to File, Import, and we're going to import another STL file. This time, let's import the crank. Again, we're going to rotate this 90 degrees and move it up. To set up the math function that's going to control the handle, we're going to use animation nodes. Animation nodes is a plugin for Blender that you can download as seen in the description below. Start working with animation nodes by moving over to the animation tab in Blender, going to the upper left hand corner in one of these windows, and opening up a new animation nodes window. We're going to need an animation nodes tree and then add our object to it, as seen here. To set up the animation nodes, we need to create an object and set it to the crank and handle object. And then we need to be able to move the coordinates of the object, such as the rotation, the position. To do that, we need a transforms output. And we connect the object to the transforms output. This is going to override our default settings, so we need to set those back. The z-axis will be 20, and the rotation on the x-axis will be 90. In order to control the position data, we need to set up a way to control the animation. An elegant way I found to do that is to use the time step, or the current frame number. To do that, we're going to do this. This frame number is going to allow us to hit the play button on the animation and have the x and y values automatically calculated by animation nodes. We're going to be using math's sine function and cosine function for the x and y positions, and we're just going to use a standard multiplication function on the rotation. In order to control the speed of the animation, we're going to stick a divide node directly after the frame number node. That will be globally changing our animation speed. Coming directly out of the frame numbers division node, we're going to connect a cosine function and a sine function. Those two nodes are going to both connect to a multiplication node, which will control how far our crank will move in the x and the y direction. And from there, we're going to use the cosine function to control our object's x value, and the sine function to control our object's y value. So if we try to hook up our multiplication function to our object's location, it'll automatically create a combined vector node. That combined vector node allows us to add 3 positions, one for the x, one for the y, and one for the z. If you've made it this far in the tutorial, this is what your node tree should look like. Fiddling around with the frame number as seen here will show you how the animation actually works. Now it's time to set up the rotation. The rotation doesn't involve any sine function, so it's going to be a lot simpler. To get the rotation all wired up, we're basically going to take the division function that comes out of our frame info, pipe that into a multiplication node, and when we attach that to the rotation input on our object transforms output, it's going to create a combined Euler, where we're going to set the result of the math function to the z and put our x rotation back to 90 so that it's in the correct location. It's going to look something like this once you're done. From there we get to the tricky bit, which is attaching the pistons to the screw holes of the crank. This is going to involve some object parenting. I'm going to use a script that helps out with this called Dynamic Parent. I'm going to put a link to that in the description, and you can install that if you would like. Otherwise, you can set up the object constraints as they will be shown. I'm going to start off by importing the Piston's STL file and dropping it into the scene here. Once I have imported the piston, I'm going to position it in the scene so that I can get ready to place an empty object that will act as our parent. Right here, I'm going to set the object's origin to its center of mass. This will align the origin to a place that's more easy for me to work with. Once I'm done that, I'm going to place an empty sphere where I'd like this piston to rotate around. Well, technically it's not rotating, but it is following the position. This will act as our pin. I'm going to position the sphere where I'd like. Once I have the rotation point set up, I'm going to use the Dynamic Parent tool to parent the piston to the axis. Using the Dynamic Parent tool in the Scene Layout tab, I'm going to first click on the Piston 1 axis and then click on the piston object, go over to the Create Dynamic Parent button and click it. To prevent problems in the future, I'm going to go ahead and clear the animation data that gets created using this tool. Once that's done, I'm going to go ahead and go into the constraint and disable some of them. For example, we do not need to control the rotation. We only need to be controlling the X and Y positions of these pistons. I'm also going to set up the shading here just so that everything is easier to see. With everything being the same gray, I can't see what I'm doing. From there, the rest of the pistons are the exact same process. You're going to create an empty sphere and add a piston object. So you're going to align the piston object to where you'd like it to be. Then once you have your empty sphere in the pin location that you'd like to parent that piston to, you're going to first click the empty sphere, then you're going to click the piston, holding control, click the Dynamic Parent button. That'll attach the object to that piston. Then you're going to disable the rotation constraint, clear the animation data, and you should have a piston that follows the empty sphere that you created as the screw or the pin, and it should go up and down with the rest of the animation. For reference, this is what my setup looks like. This here is the scene collection, and this is the animation node's final tree. If you'd like to see more work with animation nodes and more information on how to create animations like these, leave a comment in the description. Thank you for watching.